myself Manjunath, and I'll be explaining how low code will work in by using the PyCaret. This is the assignment 2 where I'll be explaining, and there are a couple of things like how to like install the PyCaret and how to run the basic ones. These are the tutorials for that. Like from the PyCaret docs, we can get the collab parts and binary classification, multi-classification, regression, and etc. So on, like I have 8 different modules here, so explaining like one by one I'll be saying all. Here is the task of that, like binary and the classification, binary and the multi-class, and the regression, clustering, and anomaly detection, and associate rule mining, and the time series, which has a univariate without exogenous variable and with exogenous variables. So these two are being performed here, like all 8. So I'll be explaining in an order. To go with, first one is the binary classification. For each and every module, like I'll take one dataset that are pre-built datasets from the PyCaret, and few of them, like I downloaded the datasets from the Kaggle, and I'll be using them as in the part of this. So as of now, like I'm going to binary classification. This is the binary classification where I'm not reconnecting to it, as I have many collabs as I've been running on this. So I have 3 different accounts of mine, so I use them to split 8 different tasks into the same time. Like I'll try to cover within 10 minutes or 15 minutes, depending upon the runtime and etc. So basically, PyCaret is an open source low code machine learning library in a Python. They had automated some machine learning workflows. It is an end-to-end machine learning and the model management tool that exponentially speeds up the experiment cycle and makes us more productive. And it's a very simple to install. Like for example, for Python tools, TensorFlow and other things, they might take a lot of time, but for simple modules like a binary classification or regression kind of tools, we can compare the which is the better fit algorithm and etc. on this. So I'll be performing a binary classification code for this. So for installation, we need at least Windows 7 or later, and Ubuntu 16.1 or updation, and Python 3.9 for Ubuntu only, and Python 3.7 to 3.10 for either Linux, Mac, or not Linux, Mac, or Windows operations. To install, first we need to run the pip install PyCaret, then the PyCaret full. So it's a basic one, and here the PyCaret full means it has additional parameters like the PyCaret analysis, MLOps, and parallel, and the test. So these all will be as a part of full one, where we'll be uh, uh, installing all that via this one command. And later on, if we I just ran this command, so this is how it might take around 5 minutes, or like around 1 minute maybe, possibly, by installing the, depending upon all the packages and all. So it will take a few minutes to import that. So once the PyCaret is done, then we have to start with the model. And here the PyCaret classification model is supervised learning tool for categorizing data into groups. It predicts a categorical label, like whether the customer is default or a credit payment. So I'll be using a pre-built credit datasets here. So that has to say whether he had the credit or not. This model supports both binary and a multi-class problem, and includes the data processing for a set of functions. It offers overall 18 built-in algorithms and various plots for performing analysis. So here is the PyCaret data sets. Like I'm importing the get data. Like it's a model where from the PyCaret we can import few of the comments. Like here I use a credit or iris or any kind of data set I can use here. So for binary classification, I'm using credit. So it has a couple of parameters like a limit, sex, education, marriage, age, and etc. So here is a default one that indicates whether the payment is done or not. So after this, the setup, the function initializes the training environment and create a transformation pipeline. So once it's done, like it will create a transformation pipeline. It must be called before executing any other function in a PyCaret. It has only 2 required parameters, that is data and target. The target is the which column we are specifying here for that, and the target is a default one where I'll be setting to the default variable. And the session ID is, I can give any random session ID, like here I give 111. Maybe you can give whatever value like is possible. Like it will go to that particular section and it will check the other things, like whether its folding number is 10, current GPU jobs and usage of GPU and etc. Like it will show the all the basic things that has in it. And other setup is successfully executed in Python. This information appears summarizing the experiment detail. Like here, the session ID, target type, original ID, transformation, and numeric features are the features of it. Whether the numeric value is 0 or 1 or yes or no kind of. If session ID is a pseudocode random speed of and it provides a generated and shared across the function. And in numeric features, the number of features classified the numerically. So it has that one. So PyCaret has a two APIs that will work. So functional as seen as above, and the object oriented API. So as a object oriented API, it in the, executes a function directly. You will import the class and execute methods of a class. So here is a importing class experiment in the init in the class. So we have the class and we have experimented the thing here. And the init setup for the experiment. Here we have that data, target, default, and session IDs as well. Like I have just run the init experiment here. And post that we can compare the modules. For the comparing modules, we need to evaluate all the available modules in the library across the validations, uh, like a cross validation and other, by checking which is a better fit for this. And the output of a second grid shows the average performance of the each module. You can review the evaluation matrix and during the cross validation with getting the confusion matrix and the other plotting technologies as well. The compare the baseline module. Here is a baseline module that has k SVM, k nearest neighbor, dummy classifier, etc. These are the pre-built modules which has like across 17 or 18 modules we have. So here it shows the accuracy and all. Here the cal boost classifier, he giving the highest accuracy to compare with the other modules. So once it's done, like I compare the models with along, and this gives a best fit for this. And post that, if we go to analyze the model, here we can use the plot model functions and to analyze the training model and the test models. So your retraining model is a certain classes where we'll be using to plot the thing. Like I have imported the plot modules, like plot module from the PyCaret, where the best model is the previous one, like whatever we got it out of this. And the here I'll be performing a confusion matrix. So the confusion matrix is a visual representation of this performance for a classification model by displaying the code of a true positive or a true negative, and a false positive and a false negative. So these four are the categories for the confusion matrix. So here are the possibilities of that. Like the true negative and the false negative are displayed in this format, like 1 1 and 0 1 and 0 0 and 0 1. So in this format. And once it's done, the plotting AUC area under the curve. For this is the graph for that. And the plot best plot, and the plot module is a AUC, and here the plot module is a confusion matrix. And once it's done, then I'll be getting the feature, like which is a better one for this, for feature importance and variable importance. For alternative plots, the function is a evaluate model. When we use the evaluate model, it uses a notebook environment as the uh, relies on IPy widgets and other tools. So here is the evaluate model. That function displays an interactive visualization of the various performance metrics and the best performing the model of the notebook. So here the raw data, simplified computer, and the CalBoost classifier. So here it shows the CalBoost classifier is a better accuracy for overall if we check with this particular data set. So it works like that. And leaving that, we need to predict the modules. So once we added the Caltrain predict test set, then it will check with the model accuracy and AUC recall and all other tools to it. And once it's done, the show prediction of a head, it will show the first 5 features of it, like out of many columns and thing. Like it will only display the 5 rows and the 26 columns of it. Cause like here I have the 26 columns, like from payment 1 to payment 25, etc. And by default will be the prediction score of that. And once the code is done, the copy data from drop class variables. Here like I'll be dropping the default, and like I haven't been replacing that with a head node, where the payment is done. Like here the prediction score is removed, and like here by default, like it will show till the payment ATM 6. So it's like that. copy the data and dropping the class variables. It works like this. And the predict modules on a new data, like on the new data, like I'll be predicting the models whether it's performing better or not. So here it's showing 0.75, 0.87 and etc. This is the prediction score and a prediction label of it. Once it's done, then we need to save the model. So at last, we can save the entire pipeline on a disk for later use, using a PyCaret save model function. So here is the starting pipeline where, like, this is the first experiment I just showcased, that the starting pipeline as a save model, and the best model it will take by default of it. And once the same model is done, then the load pipeline will be performed in the load pipeline. The same starting pipeline use case has to be sent here, and once it's done, the transform pipelines and a model is successfully loaded. Here the pipeline number inputs and transfer the simple imputer and the simple imputer for this, and the model of the cat boost classifier is the model for binary classification. So this is about the binary classification. Next we go to the multi-class classifier. It's also same as the installation part, and everything works as the same, but here